Good morning, guys. We are learning about 7.2 similar polygons today. You will be able to use proportions to identify similar polygons and solve problems using the properties of similar polygons. So our vocab here, a similar polygon has the same shape, but not necessarily the same size. So guys, last semester and recently, we've talked about congruent shapes. They're exactly the same shape, exactly the same size. The angles are the same, the side lengths are the same. Everything is the same about them, okay? Similar polygons have the same shape, but can be smaller or bigger. So two polygons are similar if and only if their corresponding angles are congruent and corresponding side lengths are proportional. So when we were looking at congruent shapes, the sides were exactly the same, the angles were exactly the same. With similar, the angles are exactly the same still, but the side lengths have a proportion, just like we saw in 7.1 when we were setting up proportions. So, in the diagram below, ABCD is similar to WXYZ. Also, guys, when we were doing congruences, we learned that order matters for congruent statements. Same thing here with similarity statements. The order matters, okay? So angle A is congruent to angle W. Angle B is congruent to angle X. Angle C is congruent to angle Y. And angle D is congruent to angle Z. The order matters in your similarity statement. That means the sides here are proportional. So, for instance, segment AB is proportional to segment WX. Now, how do we know that? We set up fractions to check. So, if you look over here on the right side, these are the corresponding congruent angles, just as I was talking about with our similarity statement. And then we also have our proportional sides. So AB over WX is proportional. So AB, that segment, is 15 units. WX is 5 units, so that reduces to 3 over 1. If we actually look at all of these fractions, we have 12 over 4 for the next one, 21 over 7, and 18 over 6. You'll notice that they all have the same ratio. That has to be true because of this proportional side lengths idea. So we are going to list all pairs of congruent angles and write a proportion that relates the corresponding sides. So notice that this is a similarity symbol here. It's not congruence. A single squiggle means similar. There's a similarity statement is similar to. So we can look at this similarity statement to know which angles are congruent. We know angle A is congruent to angle R. Based on this, angle B is congruent to angle S, and angle C is congruent to angle T. So I can write these things out. Angle A is congruent to angle R. Angle B is congruent to angle S, and angle C is congruent to angle T. Remember, angles are still congruent. Side lengths are similar. We have to set up a proportion. They aren't equal to each other, okay? So we know segment AB is similar to segment RS. So we have AB over RS equals, we'll look at the other segments as well, BC over ST, which is equal to AC over RT. Now, if you'll notice, I did not mark them as congruent because they are not congruent. I just did like some weird squiggles and stuff. Also, secondly, everything on top is from this shape, and everything on bottom is from this shape. You have to be very careful to match things up appropriately, so that way you don't have the incorrect fractions, which would make them not look like they're proportional, okay? So this next question says, if triangle GHK is similar to triangle PQR, determine which of the following statements is not true. So it says angle HGK is congruent to angle QPR. That is true. They are both the first thing. These angles are congruent to each other, so that's not good. Then we have angle K congruent to angle R. I guess I'm skipping over to C. Angle K congruent to angle R. These are both the third things in the similarity statement. They are congruent to each other. So that is true, which means this is not our answer. We have our proportion here, GH over PQ. Okay, those are similar sides, so they're in a fraction. And then GK over PR, those are also similar sides. We got lucky this time, they're orientated the same way, so we don't have to like shift one shape around. So this is a true statement, so that's no good. That leaves us with D being our answer, our not true statement. Let's check it. GHK is congruent to angle QPR. These are not in the same spot in the similarity statement. We've got H here and we've got P here, meaning they are not congruent angles to each other, which means D is our not true answer, or it's just our answer, okay? On the next page, we're going to talk about our ratio. So the ratio of the lengths of the corresponding sides of two similar polygons is called the scale factor. The scale factor depends on the order of comparison. So order does matter, guys, however it asks. We talked about this on our last lesson as well. So in our diagram, triangle ABC is similar to triangle XYZ. We have the scale factor of ABC to XYZ is 6 over 3, or 2. Notice, this one only gives you two pieces of information. It only gives you 6 and 3, so you hope that they match up, but you should really check. So AB is the first segment in our similarity statement, which means that matches up with XY. So we do have the similar sides, even though they're not orientated the same way. One's rotated compared to the other. So if segment AB is 6, and segment XY is 3, since the 6 is mentioned first, it goes on top, and since the 3 is mentioned second, it goes on bottom, so then you reduce to 2. If we were to reverse these, triangle XYZ to triangle ABC, 6, well, the scale factor looks different, because now the 3 goes on top and the 6 goes on bottom, so we have 1/2. So be very careful about your order here. Make sure you get them in the correct order. So we have some examples. Identify similar polygons. Jan is designing a new menu for the restaurant where he works. Determine whether the size of the menu is similar to the original menu. If so, write the similarity statement in scale factor. Explain your reasoning. So it specifically says new menu is similar to the original one. So we're going to go new to original. So we have the new over the original. So our new menu, we have 12 over 10. And we're going to see if that's the same as 14 over 12. If this checks out, then we know that these two menus are similar in shape. If it does not, then they are not similar in shape. So I can either write these as a decimal, or I can reduce my fraction, or I can cross multiply to check. So I'm going to show you all three ways. Method 1, write these as a decimal. So 12 divided by 10 is 1.2. Is that the same as 14 divided by 12? Type that wrong. 14 divided by 12. No, they have to be exactly the same, not rounded, okay? So this is not the same, meaning that these are not similar to each other. But I'll show you our other two methods as well. Method 2, reduce your fractions. 12 over 10 reduces to 6 over 5. And 14 over 12 reduces to 7 over 6. These are not exactly the same fractions, so once again, not similar. Lastly, you can actually cross multiply to check. So we would have 144 equals 140, which is not true. So in all three cases, they each tell you that these two menus are not similar to each other. So to write a not similar statement, we're going to say rectangle, parallelogram, whatever. A, B, C, D is not similar to F, G, K, H. Okay, so you can pick your favorite of the three methods here, decimal, reduce fraction, or cross multiplying, to check. Take a second, try this you try, see if these are similar or not. Alright, so Talia is a wedding planner who's making invitations. Determine whether the size for the new invitation is similar to the original. So look here, new to original again. If so, write the correct similarity statement and scale factor. So we're going new over original. Remember, order does matter. So we have new is 16 over 8. And we are trying to see if that is the same as 12 over 6. Pick your favorite method. I know if I write this as a decimal, 16 divided by 8 is 2. 12 divided by 6 is 2. So that looks like that checks out. If I reduce my fractions, I get 2 over 1, or just 2. Or if I cross multiply, 16 times 6 is, oh, sheesh, that's not what I wanted. 16 times 6 is 96. And I happen to know 12 times 8 is also 96. So with all three methods, these all three check out, telling us that these are similar to each other, the new to the original. So since I'm writing new to original here, I have new is F, G, H, I is similar to, not congruent, guys, similar to B, C, D, E. It also asks for the scale factor, which we happen to already find here twice, actually. Our scale factor is 2. Okay, it's just the fraction of how they're related. And since we already did new over original, we've got our answer. Okay? We're actually going to pause there today. We'll save the rest of these notes for our next class time. All right, guys. Bye.